Hello there. Welcome to another problem session. So today we are continuing to do the problems from the 2024 JEE. So this is 2024 JEE Advanced Physics Paper 2. Okay, and this is from India. Okay, so this is actually an interesting problem of superposition and Gauss's law and all kinds of stuff, right? Superposition, Gauss's law, two concepts here. So we have two sources of electric field. So you have a this is a charge on it, and this one has, because infinite wire, it has a charge lambda per unit length 5 nanocoulomb over meter. And then we have this a spherical shell with tiny hole here and a tiny hole here for this wire to go through. On this you have kind of distributed evenly a net charge Q total equals to 10 nanocoulomb. Okay, so unless you remember the formulas for electric field and electric potential from these charges, etc., you probably have to work it out. So the potential is always minus E dot dl from reference to some point P, assuming potential at reference equal to 0. Okay, so it's going to be, otherwise it's going to be Vp minus V reference. Okay, so otherwise that will be the case. So if you know the electric field, you can immediately get the formula for potential. I think they want you to derive the formula. So let's do for the for this infinitely long wire, and if you are wanting the electric field over here, your lambda here, what you this is cylindrical symmetry, so you do flux through this, and flux through this area is that way and electric field is that way. So for the edges, your flux will be 0. Edge will be 0, and the same will be the case for here. But flux through here from the side, flux from the side will be because the electric field at the same distance from the wire will be the same. So it's going to be let this distance be s, then it is going to be so electric field at s, at distance s, and let this be L times 2 pi SL. That will electrify us. So through the now the Gauss's law will tells us that if I add these fluxes, phi E plus phi E plus phi S, of course these are 0, that's equal to amount of charge enclosed over epsilon naught. Q enclosed over epsilon naught. And what's the Q enclosed? Q enclosed is lambda times L. So these are 0, and this is ES 2 pi SL for this. So L cancels out. So E at any point a distance s away is actually a function of s is equal to lambda over 2 pi epsilon naught 1 over s. So if I wanted to get a potential from the charge on the wire, all I had to do was see if I wanted potential over that point P. And so I will pick a reference to P. I'm going to just integrate it, right? So V at P minus V at reference will just be minus E, and I go from same direction as the electric field. So it's going to be A, E, and let's call it ds. And I go from S of the reference, the distance from the wire, to the location S of the P. And it's going to be ds. And if you look at this, it's just going to be minus lambda over 2 pi epsilon naught log S of P over S of reference. Now the P is arbitrary, so we're just going to V at any distance S. And let's see, because of this log, let's pick S reference equals 1 meter from the wire. And express this guy in meter also. So let's call that as a reference point. Then and pick V equal to 0. So that will mean right on a point on the cylinder, okay? Not cylinder, and pi on the sphere. What I'm thinking in my head is wrong. It's a sphere, okay? And this is a cylinder, so we're talking about a point 1 meter. So this actually 1 meter away. So we're picking that to be V equal to 0, our reference for this system. And we're going to pick the same reference 0 for every system, okay? Even when we work out for that. So you can't have a 0 potential for one. If you have multiple sources, electric potential, then you can pick only one point as a reference. Okay, so this is just equals lambda over 2 pi epsilon naught log S. Okay, so this we got for the wire. And about this is wire, and the second will be I need to know V of the charges in the sphere. So V of the charges in the sphere, that you can work out the same way. For a point inside, you do a spherical Gaussian. Then electric field point inside, electric field of S less than R, which is 1 meter, equal to 0. So that's one thing you can find. And another thing, I'm not going to work it out for you. Another thing you're going to find, if electric field of S more than R, that's going to be total charge over 4 pi epsilon naught, and from the center of the sphere to any time you go. So it's 1 over, and if I'm going to go this way, I'm going to just call it, I'm going to always go that way. And this distance, I'm going to call it S. Okay. So because you start to call S over here, so let's continue to call over S, 1 over S. So 1 over S is square. And if this is a positive, then the electric field will be pointed away, otherwise pointed in. So we already, if this is 0, and I integrate all zeros, so all the, so when I do V at S from a sphere, I'm going to find 0 for inside, and I'm going to find Q total over 4 pi epsilon naught 1 over S minus 1 over 1, because when S equals to 1, 1 over S minus 1 over 1. So that this will come from the reference outside. So this is what I think that I believe the test is about, to not forget that one reference thing, you know. So the reference for us is the same reference. So with that said, let me erase this and kind of summarize the results and then plug the numbers in. Okay, so we are so V at any distance S is just this guy if S is less than 1, lambda over 2 pi epsilon naught log S if S less than R equals to 1 meter, and is this coming from wire, charges in the wire, and then this stuff here plus Q total on the sphere 4 pi epsilon naught 1 over S minus 1. And you can see for S equal to 1, this is 0. So reference is S equal to 1, V equal to 0. All right, so we need to kind of use these numbers, and so we can make it 4 pi epsilon 2, 4 pi epsilon 2. So it says, what's the potential difference between these two guys, right? So this will be used for S equals to R, and this is going to be used for S equals to at P, and we're supposed to get the difference between them. Okay, so you have a minus lambda is 5, and this is nano. Everything is nano. So I'm just going to leave that nano because this is nanocoulomb and nano. There's also nanocoulomb, so both of them will be nano. So minus 2 times 5 times 9 times 10 to the power 9 using this, and log 2. So log 2 is going to be 0.7. Q total is 10 times 9 times 10 to the power 9 for all this stuff, times 1 over 2 minus 1, and then it's going to be minus, and minus becomes a plus. The same stuff, 2 times 5 times 9 times 10 to the power 9, and this log half, which is minus log 2. Minus log 2 is minus 0.7. So this is the same as that with the same sign, so it's going to add, and we have a whole bunch of common factor. This common factor, so 10 times 9 times 10 to the power 9, and it's in the nanovolt because we left the nano around, and this was 0. Minus 2 of this, so 1.4, and this is going to be minus 0.5. Okay, so, and if you want to in volt, then we have to get rid of this. So minus 90 times 1.9. Okay, so I did a quick calculation, and this is minus 171 volt. So that's the answer. So it's a little bit long problem, but I think it's worth kind of reviewing some of the concepts that went beyond the just doing the problem. If I had to do this problem, I'll probably kind of remember this. I remember the log S formula in my head and all the other formula also. But keeping track of the reference is, I think, the main place where people probably made mistake when doing this problem. So make sure that you understand the role of the reference when defining the potential. Okay, so so much for this problem now. I'll see you in another problem. Okay, bye.